This is an rate of change or exponential growth and decay sum. So every sum will have an exponential function question, and this is an exponential decay sum. So let me do a little bit of a review here. When we have an exponential function sum, so exponential growth and decay. So when we have something like this, y equals to some constant e to the power some other constant t, or y equals to some constant plus another constant e to the power another constant t, this is an exponential growth. So this is a growth. So it means it is actually y equals to e to the power x. Instead of x they're using t. So the picture looks like this. So it is growing like this. So y equals e to the power x, this particular picture looks like this. So it is growing. So we call it exponential growth. Now when we sketch this particular growth, it has to be based on time. So for time cannot have a negative value, so it usually starts from here right away. It looks like that. So the growth looks like that, so it's a growth. Now for decay, it is going to be y equals to a e to the power negative this. So when you have a negative t, it's a decay, or it could be a plus b e to the power minus c t. So that's a decay. Decay corresponds to the sketch of y equals to e to the power minus x. It's a transformation of f minus x. That means it's a reflection on the y-axis, and it looks like this. Looks like this. You just reverse this. It looks like this. Let me draw it a bit more properly. If you reflect this on the y-axis, it looks like this. Got that one here. So this is what it looks like. So when you talk about growth and decay, this one is rapidly increasing, so rapidly we call it exponential. Exponential means very rapidly, and the other one is decreasing very rapidly. So that's exponential growth and decay. Now if you take a look at this particular sum, it has a negative sign, and it is also mentioned that it's an exponential decay sum. They have also mentioned it's cooling down, so it is slowing down. So the first question, find the value of t when the substance started to cool. Start means initial, at the beginning. That will be the first question all the time. So at temperature equals to 0, at time equals to 0, the temperature capital T, 20 plus 60 e to the power minus 0.1 time is 0. So e to the power 0 is 1. It will be 20 plus 60 into 1, that means 80. So the answer should be written down as 80 degrees Celsius. Remember, this is the unit. You have to write it down like this. In question number B, again in your exam, do it one after the another vertically. Don't do it side by side. It's a bad idea. So explain why the temperature of the substance is always above this. Now this is the concept of the asymptote. It's a concept in sketching, but this is how you should remember it. You have to write, since e to the power minus point t, this exponential portion, this exponential portion, this thing is always greater than 0. If you take a look at the picture here, this e to the power x, e to the power t portion, this is always above this line, above this line, above this line. It cannot be equal to 0. It cannot cut that line. That's called asymptote. Because of the asymptote, so what we have to do, this has to be greater than 0, right? So if you have put, if you write, let's write it like this, for e to the power minus 0.1 t equal to 0, we can write temperature T is 20 plus 60 into 0, which is 20. So the T has to be equal to 20. But explain why the temperature of the substance is always above 20 degrees Celsius. Since e to the power minus 0.1 t is always greater than 0, T will always be greater than 20. And that is the explanation. Now the sketch. So it will be greater than 20. Always be greater than 20. So question number C is the sketch. Now one thing about the sketch is that the first thing is the labeling. This is the temperature, this is the time t, and this is the temperature t, and this is the origin. Now let me show you how this sketching should be done. Now this one for growth and decay. First of all, let's talk about decay, because this sketching looks like this. If it looked like this, it would be this portion, but we will not use this negative portion because time cannot be negative. And when we are talking about exponential growth and decay, we are talking about with time what's happening. So only this portion will be there, and this one, it will start from here, A. This will be A, this will be the T, and this will be the y-axis, this will be the t-axis. So this is, it starts from here, the coefficient here. This is the transformation AFX. So it will be like this. It cuts at the point 1, so 1 into A is A, and this will have no effect at all. The constant, this constant Fx, it will have no effect at all, because it usually refers to where does it cut the x-axis, and it doesn't cut the x-axis. So this will be absolutely no effect at all. So this will be the picture. On the other hand, if you want to draw this picture, this is this one. If you want to draw this one, this picture would look like this. So it will be raised by a unit because there is plus a. That means the picture is raised by a unit, and that's the asymptote. You don't usually see the asymptote, but if I remove this x-axis, you will see there is an invisible asymptote here. So there is an asymptote which is covered by the x-axis. So if you write plus a, so the asymptote that was in 0, that asymptote would now be at a. So previously, so if the picture would now look like this, and previously if this was at b, this would now be at b plus a. It will be raised. This is what the sketch will be. This is something that needs to be memorized, and this will be the sketch for this one. So it will be raised and the asymptote can be seen. So for this particular sketch that we have to do, so our sketch is, this one is plus 20, so our asymptote would be at 20. So 20, this is our asymptote. Now it is 20 plus, if this 20 was not there, remember it would be 60. So I showed you here, if this 20 was not here, if it was just this constant, it would just be at that constant. But now since we have 20 added to this 60, be parallel. So since now we have this 20 added to the 60, it will be 60 plus 20, 80. So this will be 80. We actually found it when t equal to 0, cuts the y-axis here. This is y, this is t. So this will be the sketch. Now in question number D, you have to find when t equals to 60, what is the value of the time. So t equals to 20 plus 60 e to the power minus 0.1 t. At t equals to 60, we can write 60 equals to 20 plus 60 e to the power minus 0.1 t. So that would be 60 minus 20 is 40. 40 equals to 60 e to the power minus 0.1 t. So therefore if you send this 60 to the other side, it would be 4 by 6. That means it would be 2 by 3 equals to e to the power minus 0.1 t. So we can write it e to the power minus 0.1 t equals to 2 by 3. So therefore, and this is the formula. You need to remember the formula. Exponential solving. If you have e to the power x equals to a, then x equals to ln a. That's what happens. So this one is going to be minus 0.1 t equals to ln of 2 by 3. So therefore t equals to ln of 2 by 3 divided by minus 0.1, and let's bring out our calculator. It will come in handy here. So it is ln of 2 by 3. It's a very good idea is always to find out the value equals to, so ln of 2 by 3 is this thing, divided by bracket, be very careful when you do divisions here, minus 0.1. so this is going to be 4.055. 4.055. Now the question was, write down your answer to two significant figures, the value of t. So the answer is going to be, two significant figure means 1, 2, so 0 will become 1, so 4.1, and the unit is very important, although not for this particular thing because they just ask for the value. If they ask for the time, then the unit has to be, time is in minutes, so it's a good idea to keep the unit all the time, but even if you don't give for this particular sum, you will not lose any points. So this will be 4.1 minutes. That's the value of t. Now let's do the next one. Next one is question number E. It's the derivative. So dt by d small t is, if you differentiate 20, it will be 0. So remember, the derivative of e to the power anything is that thing, remember that. So the 60 would be 60, e to the power minus 0.1 t is minus 0.1 t, but remember the chain rule. So the chain rule is derivative of minus 0.1 t, which is going to be minus 0.1. So this would be minus 6 e to the power minus 0.1 t. That's the derivative of exponential function. This is the rule. Now question number F is, find the value of t at which the temperature is decreasing at a rate. Remember, decreasing means something is negative, rate means something by dt. If I say temperature rate, it means d temperature by dt. If I say rate of y, it would be dy by dt. The rate means dt. So the question is, the temperature rate, meaning when dt by d small t, rate means dt, temperature, is equals to 1.8, decreasing meaning minus 1.8. You have to remember, decreasing means negative. So when dt by dt is minus 1.8, you have to find the value of temperature. So how do we do this? We just do this by this. Therefore you just plug this in from the previous sum. So minus 6 e to the power minus 0.1 t equals to minus 1.8. That means e to the power minus 0.1 t is minus 1.8 divided by minus 6. So you cancel this off and you cut this off. This is going to be 0.3. So e to the power minus 0.1 t equals to 0.3. Therefore minus 0.1 t equals to ln 0.3. Therefore t equals to ln 0.3 divided by minus 0.1. So let's find the value out. ln 0.3 is equals to this one. Find this one first, then divided by bracket minus 0.1, bracket closed. So this is going to be 12.0397. 12.0397. Now this is a relatively accurate answer, 12.0397. Now remember, we found the value of time, small t, but the question was you have to find the value of capital T, which is temperature. So you have to plug this value in. Hence temperature equals to 20 plus 60. Now I can just do this. Instead of going through this trouble, I can actually put the value of e to the power minus 0.1 t. The value of e to the power minus 0.1 t is 0.3. I can just plug this in, 0.3. So it will be, let me calculate this directly, 20 plus 60 into 0.3, that will be 38. So the answer is 38 degrees Celsius.